Hello YouTube, thought we'd do another video here. This is going to be part 2 of the video series on guiding you how to build a interface circuit so you can hook up your Midland MXR10 or the Retevis RT97S GMRS repeaters to your computer using the data port that's on the repeater. So this is video number 2 or part 2. This video we're going to talk about the PTT circuit, and I'm going to show you, I believe I have a working circuit for that. So that's what we're going to talk about in this video. So one of the things that you're probably wondering is, well, how do I know what the pinout should be for these repeaters? Well, I have the pinout diagrams. So if you go to the Midland DB9 pinout, you can see here that the PTT needs to be an active low, meaning 0 volts to turn the transmitter circuit on in that repeater, which is also the same in the Retevis one. If I go to the Retevis pinouts, it is the same exact pinout. Needs an active low. Again, needs 0 volts to turn on the transmitter of the Retevis repeater. So that's how I know what this should be. The one thing that I do like about the Midland diagram is that they actually have a little bit more information what's going to be helpful for us in the future. And the reason being I say that is because if you look on the microphone in and the speaker out, they give you some values here. 30 microvolts for 60% modulation or 60% volume. So I have a number here to go by. Same with the speaker out into a 32 ohm load, 250 milliwatts. Okay? So again, we have some numbers here to work with. And this is going to be important because depending on what software you want to hook this repeater to, you may need to lower the volume. Now the problem is, as you know, these repeaters do not have a volume control. So we're going to have to add in the circuit a variable resistor. That's going to be the audio part of this video series. We're not going to do it today, but we're going to have to add a variable resistor. And what a variable resistor is, think of it like this. Back in the old days with old stereos, you had the turn knobs for volume. You turn up your volume. That used a variable resistor. So think of it like a volume control. And we're going to need that because you may have to turn the volume down, whether it's a speaker coming out. You may have to turn it down because it may be too high for the software that you're trying to run it with. Whether it's Zello, whether it's some other type of software. And obviously there's no volume control on the repeater itself. There's some volume control on the computer, but that may not be enough. So that's why we got to add that. So we're going to need to come up with what values we got to add there. But that's not going to be until we do the audio part of this video series. So for now we're doing the PTT, and let's go ahead and I'm going to show you here how I have this. I apologize, my part 1 video, I did not realize my little fancy marker was not writing on the screen on the meter. But we're going to want, when I key this up, when I make this software turn on the PTT, we're going to see voltage here 5 volts or higher. It's going to be a high. And remember what I told you in that one video, if you go to PTT configuration, we do not want to check none of this. Because like I said in that video, if we check something, if we check one of these, yes, we can avoid building a circuit, but the consequence is, like I said, if the simplex software exits or crashes, it's going to enable that transmitter is going to be turned on. It will stay on until the software starts. The simplex software, that is. So that's why you don't want to check these. Yes, you get to avoid building a circuit, but the consequence is like I just told you. So we're not going to check that. So let's go ahead and go back to here. So you're going to see a high up here when I do this. I have a Baofeng handheld hooked up, and the reason why I'm using a Baofeng is because that also requires the PTT to be active low or 0 volts. So that's how I can test this circuit. I can use the Baofeng. There's a schematic on a Baofeng that you can look and see for yourself. I made a special test jig, which you can't really see here, with this K cable. It goes to a little circuit board that has wires coming off it, so I can use alligator clips to hook up my little circuit here. I also have a Retevis RT85 radio here. If this all works like it's supposed to, it's going to key up this radio. There'll be no sound though, because I don't have any sound hooked up to the circuit yet. It's going to key up this radio. Hopefully you'll see this on camera. You'll see a red light. The back display should light up. Then you'll see a green light on this radio, meaning that it's obviously receiving the signal. It's being keyed up. These are both on the frequency of my repeater. And my repeater does not have the data port, just to mention that. So at any rate, and how I'm going to key it up is we're going to go to the configuration file. We're going to do the beacon, and I did a pre-recorded WAV file that I made earlier. And when I hit test, we should see voltage up here being a high, and we should see these radios key up. So let's go ahead and give that a try. This recording is to test the PTT COM port pin to see if it's high. Perfect. It keyed up. You saw the voltage up here. I don't know if you heard my little message or not. It keyed up. This was transmitting. There's a green light on here, so this is all working the way it should. So the PTT circuit I have right now seems to be working. So that's good news. So good news, we're on the right track. Now, the other circuit we got to do, and this is going to be another part of the video, another video part, we're not going to do it in this video, is the squelch circuit. That one's a little more trickier. I'm still kind of ironing out those details on that one, but hopefully I will come up with a solution on that one for the squelch circuit. Now, I should make clear, when you go to these diagrams, these pinouts, squelch means busy. It's the same thing, whether you're talking the Midland or the Retevis. Pin 3, the busy means squelch, just to let you guys know that, to be aware of that. I'm going to show you my circuit here that I kind of built up close. Let's go ahead and turn all this off. We're going to unhook this, and we're going to move all this. I'm going to quickly show you. And I don't want to do a schematic until I know this is going to work and everything's going to work properly before I release a schematic of any type. So that's why I haven't done that. If you're wondering, well, why can we just don't draw something up quick and just slap it on the internet? Well, because I want to make sure that this is going to work the way it should. You may have to tweak it because, like I said, I don't have these models of repeaters. My repeater does not have a data port. The Retevis RT97 without the S means no data port. That's the model I have. So unfortunately, I cannot just build this circuit and say, yep, it works 110%, because I don't have those repeaters here. But I'm going to try to guide you. That's why I call this the guiding video series, because I can't build the circuit and test it on a repeater that's here. At least not at the time of making these videos. So let's go ahead and go to the microscope here. Let's go to the microscope so I can show you how I'm doing this. And there we go. Now, like I said before, I'm doing it a little differently. Here's my DB9 my USB to DB9 adapter, as you can see here. Okay, I have that. And then I use long bolts so I can connect two female DB9 connectors, like I said. And the reason why I did that, because it's easier to solder underneath. If I need to flip this around to solder underneath, I can do that compared to a circuit board. So that's why I did that. Here's my little circuit here with the transistor, like I said. Let me get a little pointer here. This little wire here is my test point. That's what I had my alligator clip hooked to. That's what showed you the 7 or 8 volts on the meter display. That's what that's for. Since I don't have the actual repeater to plug this into, I just took a test lead and I clipped it onto the collector of the transistor. And this is my ground. And by the way, that's another reason why you just can't plug this in. The ground on the repeater plug is pin 1. And the ground on the computer side is pin 5. So you just can't, that's another reason why you just can't plug these in and make it work. I have a couple of bias resistors, a diode in there to kind of help with the any spikes. That might be a little bit of overkill, but at any rate, this is what I did. The voltage coming off the computer port, which is the 7-8 volts, is reduced for the biasing of the transistor, and then the emitter of the transistor is hooked to ground, and the collector is what makes the pin that would have been on the repeater go to active low. Like I said, I clipped a clip lead onto here, and that's how I hooked it up to my ball thing. But yeah, so this is acting like a switch. High on the base turns the switch on, which is like a switch to ground, and that's what's making this do an active low on this DB9 connector. Like I said, we still got to do the squelch, we got to do the audio. Hopefully my part 3 video, let's go back to the normal thing here. Hopefully my part 3 video will be the audio if everything works accordingly. Obviously, I'm not going to worry about the audio part until I get the squelch to work. Like I said, I'm trying different ideas for the squelch. I'm trying to iron that out. Once I get that figured out, and then I will do that video on that. And like I said, once I get all this kind of fine-tuned, then I will post the schematic and have you guys build it yourself. That's what the plan is. I don't want to post anything until I know it's going to work. Like I said, I don't have these repeaters here, so I'm going by the data I have in front of me. You may have to tweak it a little bit. Hopefully not too much, though. You may not have to. If I can do this just right, you may only have to adjust the volume with the little screwdriver using the variable resistor like I mentioned. That's what my goal is, at least. So, at any rate, hopefully this video is helpful. If you have any questions or comments, please post them down below. Please subscribe. Thank you and have a good day.